Today we're moving on with our rational unit. Our topic is rational numbers. Your learning target today, you can define, evaluate, and compare rational numbers. So today we actually define what a rational number is. A rational number is any number that can be written as a fraction. If a number can be written as a fraction, it's rational. For example, 3 can be written as 3 over 1. It's rational. 2.2 can be written as 2 and a half. It's or 2 and a tenth. 2 tenths, 2 and a fifth. Good gracious. 2 and 2 tenths, which is 2 and a fifth, which is a fraction, which means that it's rational. Okay, so given that any rational number is a number that can be written as a fraction, we need to know how to deal with fractions. So one of your targets today is creating equivalent fractions. Nothing new. Review. It's how you either multiply or divide. Divide, I can spell. Divide the numerator and the denominator by the same number. That's how you come up with an equivalent fraction. We had this kind of homework in our last lesson. Coming up with equivalent fractions. There's an infinite amount of possibilities. You decide what you like best. So I'm going to write 3 equivalent fractions to the given. A 4. Well, I know I'm going to go 3 out. And you always go back to the original. So the easiest thing to do, times it by 10. That's the easiest thing. Hey, maybe I want to times it by negative 5. 1 times negative 5 would be negative 5. 4 times negative 5 would be negative 20. That's the same thing. Although there's negatives, what happens to these 2 negatives? They cancel out. So you still get a positive 1/4. And let me think. You could do negative 100 over negative 400. Again, I'm not challenging myself by much, but I am including integers. And I'm making an equivalent fraction. I'm just being as easy as I can. Yep.
Well, that means some kid could do 10 over 40 and then just put 2 negative signs for the next one.
Yep, someone could do that. Are they wrong? I can't count them wrong. They made an equivalent fraction. Yep, absolutely. Negative 10/35. Then I'm making 3 equivalent fractions. So I could just add a 0, multiplying by 10. Negative 100 over 350. I could divide by the same thing. It's not simplified, right? So I could divide them both by 5. That would be negative 2/7. That's equivalent. I could times them both by negative 1. That would be 10 over negative 35. Still equivalent. It is still an equivalent fraction. It doesn't matter if the negative is on the top or the bottom, as long as there's just one, because that just means the whole answer will be negative. And 2/3. I can times it by 10. It always is my favorite. Times it by negative 1. Times it by, what do I want, negative 10. Let's do that other easy strategy. Be nice to yourself. I don't care what kind of strategy you use. I try to encourage us 7th graders, because you've done equivalent fractions for so long. Include integers in there. Timesing by negative 1 or negative 2 or negative 3. Okay, comparing, that's a huge standard. Comparing rational numbers. You have to get them into the same form and then compare. So you want them to be the same form and then compare. Your call. When I say the same form, you can either turn them both into a fraction or both into a decimal. I tend to work with decimals better than I do with fractions, because fractions you have to get like common denominators and all that, and I just try not to. So I turn this to negative 0.5, this is negative 0.4, and then the others are already decimals. Now when you put it in order, you have to put in original form. So that means that I'm not going to put negative 0.5 first, I put negative 1/2. So you always have to go to the form that they gave you. So also remember, the bigger the negative, the smaller it is. So which one is the biggest negative? Negative 2. Negative 2 is the smallest number, right? Because it's the largest negative. So negative 2 would be first. And then what's the next largest? What's the next smallest number? Negative 0.5. Remember, the bigger the negative, the smaller it is. I'm trying to go small to big. And then negative, oh, yep, I know what you're going to say. You're like, wait a minute, this needs to be back in original form. It has to be. Because the MCA or any kind of standardized test isn't telling you the strategy. It's saying, given this data set, put it in order. So they give you the same data set. They don't tell you how to convert. And then it's negative 4/10. And then I have a positive 0.9. So this is trickier. The thing I want you to know is the bigger the negative, it means it's smaller. Because bigger negative implies that you're over here on a number line. If you're a big negative, you're over here. And when you're on the left of a number line, the furthest left you are, the smaller you are. That's why that's the case. It all stems to the number line. Okay, so 1/2, 1, negative 8/10, and negative 0.2. Again, I'm going in decimal form because I don't want to deal with fractions. So this is 0.5, negative 0.8, negative 0.2. So which one would be furthest to the left on the number line? Negative 0.8, right? But I have to put it back in original form. And then the other negative would be the next number. They gave it to me as 0.2. And then 1/2 followed by 1. So if you're ever confused, quick draw out a number line. It's not going to take you long if you quick draw a number line out. And then you can plot the numbers and order it that way. All right. Let's do another one. I want you to take a minute and order this next data set from small to big, least to greatest. Okay, so I know that 2/3 is 0.6 repeating. I don't know what 1/6 is, so I'm just going to briefly estimate that. 6 goes into 10 one time. So I'm just going to call it like a 0.1 for now to see, and I'll expand it if I need to. This is just estimating. 1 is 1, 5/12 I know is going to be like a 0.2 something, estimating, and that's all. So I think that I don't go that far out if I don't need to. I go per place value. So my smallest place value is the 10. So 1/6 would be my smallest number. Followed by what? Followed by the 5/12. Followed by the 2/3. And ending with our lovely 1. Okay, so comparing fractions, again, you can either convert it to, you can keep them as fractions, or you can turn them to decimals. I don't know 6/7 as a decimal, So I'm choosing to go the common denominator route and compare the numerator. You don't have to. You could turn 6/7 into a decimal if you want. You have that choice. This is 30, this is 28, right? So it looks like 6/7 is bigger than 4/5. Logically, you can also think they're both one away from their whole, right? 6/7 is one away from a whole, 4/5 is one away from a whole. 7 as part of your whole is bigger than 5 as part of your whole. But that gets tricky. It gets really tricky. 2/3 and 3/4, that I know by heart. And that's where in my brain I'm converting to fractions. I'm saying, or decimal. I know this is 0.6 repeat, 0.75, 3/4 is bigger. Again, I'm converting to decimals. This is negative 0.75, negative 0.70. Again, the number that lies the furthest to the left is smaller. So 0.75 is about right here, 0.70 is right before it. So 0.75 is the smaller one. The bigger the negative, the smaller it is. And our last learning target for today is evaluating rationals. Same strategy as before, you plug in and then you simplify. Plug the number in and simplify. So evaluate the following for A equals 6 and B is negative 5. And we're going to write in simplest form. So the 6 is going to the A, the negative 5 is going to the B. So this would be 6 plus a negative 5 over negative 3, which is 1 over negative 3. Seven minus B. B is negative 5, so it's 7 minus a negative 5 over 3A, so 3 times 6. When you minus a negative, what are you doing? So it's 7 plus 5 over 18. I'm doing a little chunk at a time. That is 12 over 18. Divide them both by 6, 2/3. Again, this relates to rational numbers because it's a fraction. Any rational number is a fraction. A plus 9 over B. 6 plus 9 over negative 5. 15 over negative 5. Negative 3. That's it.